Okay, so picking up where I left off, we were about to do magnesium sulfate. Now, one thing I want to point out is sulfate. It's not sulfur. Sulfur is spelled like that. Sulfate is different. It has that ATE ending. And one of the tips we talked about earlier is if a chemical ends in ATE or ITE, use the polyatomic handout. And this is the handout that you can get from the Moodle website and print it out. Or you can get a copy from me. I can give you a paper copy. Stop by or ask me when we have class. And this is what it looks like. And if we see here, sulfate is one of our polyatomic ions. Sulfate is SO4. It's one sulfur and four oxygens stuck together, held together tightly to act as one single thing. And we call that one single thing sulfate. It has a -2 charge. So when I do the example, magnesium sulfate, Mg is a +2. So Mg is a 2 plus. SO4, and if you want to put it in parentheses, that's fine. I won't mark that wrong if you just want to always put polyatomic ions in parentheses. Technically, you don't need the parentheses unless you're putting a number outside the parentheses. But again, if you want to get in the habit of that, that's fine with me. And we look at the polyatomic ion sheet. Sulfate is a 2 minus. Now, one thing we haven't talked about is when you have two numbers that add up to 0, you don't have to do the switch trick. So we have a +2 and a -2. If we add +2 and -2, those two combined add up to 0. So basically, all it means is we just write the two chemicals together. You don't have to worry about any little numbers because they kind of cancel each other out. Another way to think about it is if we did the switch trick, the 2 would go here, that 2 would go here. Well, one thing we always want to do is we always want to use the smallest possible ratio. A 2 to 2 ratio is the same as a 1 to 1 ratio. Well, we never write the ones. So there's a 1 there, there's a 1 there. We assume they're there. MgSO4 is our final answer there. So let's keep doing some examples here. Calcium permanganate. Again, ATE ending. So I know I am going to need my polyatomic ion sheet. And permanganate. There it is, MnO4. So, and it was calcium permanganate. Yep. Calcium right here is a +2. So Ca is a 2 plus. You can do 2 plus or +2. I don't really care. Technically, it's supposed to be the number then the charge, but if you write it either way, I don't care. MnO4 permanganate is a 1 minus. So since they don't add up to 0, I have to do the switch trick. The 2 from the Ca goes behind the MnO4. The 1 there goes behind the Ca, but I don't write the ones. So Ca, MnO4, 2. That would be my final answer for calcium and permanganate together. In this case, I do need the parentheses because there's a number outside the parentheses. We never add anything into the parentheses on the polyatomic ion sheet and never take anything out. So basically, the stuff in the parentheses, never mess with it. Okay, the last example here. And this one looks a little different. Lead 4. Bring up the periodic table here. If you notice where lead is on the periodic table, lead is right here. And if you remember, I said that a lot of the metals underneath the stairway and the metals in the D block, they don't follow the octet rule. So lead actually has a couple different versions. We could have lead that's a positive 4 charge, which makes sense because it's in the +4, -4 column. But lead can actually also be a +2. Now, I don't expect you to memorize that and know which ones are which, so again, the polyatomic ion sheet. But this time at the bottom, let's see here, how can I make this work? There we go. If you look at the bottom of your polyatomic ion sheet, I have a bunch of D and P block metals, and I tell you the charge on them. And in this case, I gave you the name, lead-4. This actually makes it easier. A lot of people get confused by this Roman numeral here, and that's a Roman numeral 4. Remember, the I's, the capital I's, come before the 5, and V is a 5. Roman numeral 1 comes before the 5. That means it's less than 5, so 1 less than 5, that's 4. If it was 6, that 1 would be on the other side of the V. So this is lead-4. And again, a lot of people get confused by this, but it's actually helping you out. You don't have to look at the periodic table. You don't have to look at anything. You know that the charge on this lead is 4. And since it's a metal, it's always going to be positive. And so we know lead. Let's look up sulfur. Sulfur is a -2 or 2 minus. So sulfur is a 2 minus. So when I do the formula for that, lead is Pb, S is sulfur, and if I do the switch trick, the 4 from the lead goes down behind the sulfur. The 2 from the sulfur goes down behind the lead. Now, if you remember when I talked about an example earlier, what was it? I think it was the magnesium and sulfate. You always want to write the formulas with the smallest possible ratio. Here we have Pb to S4. That's a 2-to-4 ratio. Well, can we reduce that? We can. So the final answer is actually PbS2. Because a 2-to-4 ratio, if we reduce that, we divide each number there by 2, we get a 1 and a 2. So a 2-to-4 ratio is the same as a 1-to-2 ratio. We don't write the 1s, so our final answer is PbS2. So hopefully that is making sense. You'll have some practice in the practice quiz doing that. There's a practice quiz on formulas, and then there's a practice quiz on naming, which is the next part of our notes here. Here's some rules for naming ionic compounds. Binary ionic compounds, basically just 2 elements. You name the positive one first, the cation, then the anion. And the ending of the second one, the anion, becomes IDE. So that's pretty straightforward. I'm going to skip down to a couple examples here. We have Na2O. Well, Na2O, that's the formula. And just like before, with the names and the formulas, you always write the positive one first. So the name is going to be in the exact same order. Sodium is a positive, oxygen is a negative. So Na is sodium. And again, this is Na2O. Sodium and oxygen, like I said, the ending of the anion, the ending of the negative ion, the second one, changes to IDE. So if we're doing sodium oxide, or sodium and oxygen, we get sodium oxide. This next example, AlCl3. Well, aluminum is the metal. That's the nonmetal. You always go metal, nonmetal. Aluminum and chlorine becomes chloride. So naming is really pretty simple, especially these basic examples. You just name them in the exact same order as the formula. If I just gave you the chemicals without the formula, you name the positive one first, or a trick is from left to right on the periodic table. The trick almost always works. Do this next one, CaI2. CaI2, we have Ca is calcium, and then iodine, remember the ending changes to IDE, so iodine becomes iodide. Try this last one on your own. Pause the video, try it on your own, and then restart the video and check your answer. So, lithium and sulfur. Li2S would be lithium. Sulf, instead of sulfur, it's sulfide. Okay, going back up to our rules here. Second type of ionic compound that you might be naming involves polyatomic ions. And I think this is even easier because as long as you remember to use your handout, you don't have to really worry about anything. You just do the cation first and then the anion. Most of the time, our anion is going to be a polyatomic ion. Every once in a while, the anion isn't a polyatomic ion, and you do the same thing about changing to IDE. Might sound a little confusing, but here's what you got to remember. If it's on this sheet, don't mess with it. Just like we never mess with anything in the parentheses, we're never going to mess with the names of any of these polyatomic ions. So, if we go to this next row of examples, MgCO3. Well, I know Mg is magnesium. And CO3, find CO3 is carbonate. And again, like I said, never mess with anything on the polyatomic ion sheet. So you don't change the ending or anything like that. You just magnesium. Magnesium carbonate is your name of that compound. Next one, if we look at Sr is strontium. And SO4, looking up here, SO4 is sulfate. So strontium sulfate. Again, never mess with any of the names on the polyatomic ion sheet. Why don't you do the next two here and pause the video, try them on your own, and then I'll put the answers up. Okay, the two examples. Ag, if you remember, is silver. And PO4, if you look at our polyatomic ion sheet, PO4 is phosphate. So silver, silver phosphate is the name of that formula right there, that chemical, that ionic compound. Last example here, that hopefully you did on your own, Zn is zinc. And NO3, we find it right here, is nitrate. So zinc nitrate is the name of ZnO3. Hopefully this is making sense. This is extremely important in chemistry, so we will be practicing this a lot. These next examples here involve metals in the DNP block. So this is going to take a few minutes. The next video will be short, but I'm going to pause this here and we will pick up in 1 minute. So we'll finish with the next video. Go watch the last video. It should just be a minute long.